Here we're going to look at two interesting problems from an international math contest that is available to all of the countries from Africa. And this is called the Pan-African Math Olympiad. So we're going to look at the 2004 edition. We're going to look at question 2 and question 3. So maybe we'll talk about question 2 a little bit before we look at the solution, just so that I can give you a verbal hint if you want to try it. And I would say maybe my verbal hint is to look at this one piece at a time. Then as you're looking at each of those parts, maybe look for some clever factoring. So if you want to go ahead and pause it, try number 2 with this hint. Now would be a time to do that because we're about to launch into the solution. Okay, so let's look at the solution. So like I said in my hint, I'm going to break this into 2 parts. I'm going to call this component right here A and this component right here B. So what that means is that my goal is 4A plus B. And notice I want to see if this thing is an integer. And I guess also built into this hint would be something like, well, it probably is an integer because this number looks wild, and if it's not an integer, well, that's kind of expected, but you would expect the unexpected on a math contest problem like this. All right, so anyway, like I said, I'm gonna set A equal to, so it's gonna be the square root of 4 minus 2 times the square root of 3, and then I'll set B equal to the square root of 97 minus 56 times the square root of 3. And this rephrases our goal as finding a simple description of 4A plus B. So obviously 4A plus B is describable in this form, but that is not obviously an integer just yet. But hopefully if we can decompose these numbers some other way, they will obviously be integers. All right, so let's maybe go ahead and work on A first. So I'll do what's really screaming out at me, and that is square both sides. So if I square both sides here, I'll get A squared equals 4 minus 2 root 3. Then I should probably get the square root thing by itself so that I can take a square again and get all the square roots out of there. So let's see, that's going to give us A squared minus 4 equals negative 2 root 3. So now if I square this left-hand side, I'm going to get a to the 4th minus 8a squared plus 16. Then if I square the right-hand side, I'll get 2 squared times 3, but that's going to be 12. So I have this equals 12. But now I can move the 12 over. That's going to give me a to the 4th minus 8a squared plus 4 equals 0. So this is a quadratic equation in a squared that we could use to solve for a squared and then a. But that's not the approach that we want to use, because if we use that approach, we'll land right back at this version of a. So we want to try to use another approach. So maybe we can factor this like the following setup. So maybe it can be a squared, something times a, and then plus something. That something is probably going to be a 2 because 4 factors like 2 times 2 and also 4 times 1, but it seems likely that this evenly splits up. And then maybe we can also factor it as a squared and then plus or minus a times something, and then again with this 2. And so I'll let you guys play around with how to figure out what these numbers are, but it's not a big jump to come up with what works is a plus 2a here with a minus 2 and a minus 2a here with a minus 2. So if you distribute all of these parts out, you'll see that it cancels down to this a to the 4th minus 8a squared plus 4. Good. But now we can apply the quadratic formula to each of these parts, and I'll skip all of the details, but that'll end us up with something like a equals plus or minus 1 plus or minus the square root of 3. So that gives us 4 choices for a. Now this is going to be one of them, but the real question is which one of them is this? Well, we can actually figure that out by some inequalities. So 2 of these are negative and 1 of these is too big, which will leave us with only one possibility. So let's see. Negative 1 minus the square root of 3, so that's less than 0, but it's also less than 1 minus the square root of 3. So like I said, each of those is less than 0. But then A, if you look up here, A is positive. And so that's pretty clear because 4 minus 2 times root 3, well, that's going to be bigger than 0. So that's the square root of something bigger than 0. But A is going to be less than the square root of 4 because we could just drop this minus 2 root 3 and we'll get something bigger. But the square root of 4 is equal to 2. So A is less than 2, but that is less than 1 plus the square root of 3. So notice we've got 1, 2, 3 of these possibilities ruled out by this inequality, which gives us one possibility left, and that is A equals -1 plus the square root of 3. So let's maybe bring that up here, -1 plus the square root of 3. So we've got our value for A decomposed in like a more useful form. Now let's go ahead and do the same thing for B. So I think we can fit it in here on the other side of the board. We're going to do essentially the same strategy. So here we'll square both sides. That's going to leave us with B squared equals 97 minus 56 times the square root of 3, like that. We can move that 97 over. That's going to leave us with B squared minus 97 equals -56 times the square root of 3. Now here we can do the same sort of calculation that we did in our first setup to get a quartic polynomial. That is a degree 4 polynomial for B. And in this case, I'll skip right to the chase, and what we will get is B to the 4th minus 194b plus 1 equals 0. Sorry, 194b squared. And again, we could use the quadratic formula to solve for b squared. Take the square root, that would give us b, but that would land up right back at this version of b. So we want to factor it another way. Maybe we can factor it like 2 quadratic polynomials with integer coefficients. And we can do that using the same kind of reasoning and trick that we did here. That is kind of a guess and check reasoning. And what we'll end up with is b squared minus 14b plus 1 and b squared plus 14b plus 1. So if you multiply all of this out, you'll get this line which is right above. But now we can apply the quadratic formula to both of those quadratic factors. And that's going to give us b equals plus minus 7 plus minus 4 times the square root of 3. And then we've got to figure out which one of these is our value. Okay, so let's maybe go ahead and do that. We can use the same kind of strategy that we did here. That is, notice that 2 of them are less than 0, and that's too small. And then one of them is obviously too big. So let's notice that minus 7 minus 4 root 3, that's going to be negative. Well, our b is positive, so that rules that one out. And that is less than minus 7 plus 4 root 3, which is less than 0. So that one's also too small. Like I said, b is bigger than 0, so I can put that right here. But then b is going to be less than the square root of 97 minus 56, where I've just replaced the square root of 3 with 1 to create something bigger. But 97 minus 56 is 41, so here we have the square root of 41. But that's going to be less than the square root of 49, but the square root of 49 is 7. So meaning this is less than 7, but then 7 is less than 7 plus 4 root 3. So let's see, we've ruled out 1, 2, and 3 of our possibilities, leaving only one possibility, and that possibility will be b equals 7 minus 4 root 3. Great. So we've got this value for a up here. We've got this value for b down here. But now we can calculate 4a plus b using these two values, and we'll see that 4a plus b is equal to 3, meaning that this thing right here is equal to 3, answering this question in the affirmative. Okay, good. So I'll get rid of this, and then we're going to look at this other question. Okay, so let's look at this second question. It's got a pretty big statement, but we'll sift through the parts that we need. So let's say you write 268 numbers around a circle, and then they satisfy the following setup. The sum of any 20 consecutive numbers is 75. And then the numbers 3, 4, and 9 are in positions 17, 83, and 144 respectively. And the question is, what number is in position 210? Okay, well, it might seem like there's too much going on here to get a handle on what's going on, but notice that the fact that the sum of any 20 consecutive numbers is equal to 75, that tells you that the first number and the 21st number are the same. And also, let's see, the second number and the 22nd number are the same, and so on and so forth. So let's maybe see if we can clean that idea up. So let's maybe put this as an observation, and that is the numbers repeat after 20. So let's maybe talk our way through that. Well, let's look at an plus 1 all the way up to an plus 19. So notice that's the sum of 20 consecutive numbers, where I should say my subscript is working mod 268, just in case I loop all the way around the circle. So for instance, if this is a sub 260, then this is going to be a 261, and we'll hit a 268 at some point, but then we'll loop back to a sub 1. Okay, so we know that this is equal to 75 because that's a sum of 20 consecutive numbers, but then we can offset this by 1. So an plus 1 plus an plus 2 plus an plus 19 plus an plus 20 also equals 75. But look, each of these expressions have big chunks of them that are exactly the same. So that means I can subtract this expression from this expression, and that'll leave us with an minus an plus 20 equals 0, 75 minus 75. In other words, we have an is equal to an plus 20. And this is going to be true for all values of n, where we're thinking down here that all of this is happening mod 268. Now we can generalize this to say that this is not repeating every 20th step, but every 20 times k step. So maybe let's write this down. So this means that an equals an plus 20 times k, and this is true for all natural numbers k. And I should say where the subscripts are mod 268. Okay, great. Now the next thing that we want to notice is that also a sub n equals a sub n plus 268 times L, and this is true for all natural numbers L. And that's really straightforward. That doesn't require anything but the fact that this loop has 268 numbers. And so here I'll just bring down this fact that the subscripts are happening mod 268. Another fact, which is going to be super important to get us off the ground, is the GCD of 20 and 268. So the GCD of 20 and 268, so this isn't hard to calculate, but what you get is that it is 4. There's a number of ways to calculate the GCD. You can do it with the Euclidean algorithm. You can do it with maybe just prime factorization. So notice 20 is equal to 4 times 5, and 268 is equal to 4 times 67. So those are the two like prime power factorizations of 20 and 268, where we're writing 4 instead of 2 squared. But that means that the GCD is pretty clearly equal to 4. Okay. But that gives us a hint that this repetition shouldn't be happening every 20 or every 268, but maybe every 4. And that's because we can express the number 4 as some linear combination of 20 and 268. So this is like using a fact from number 3, and we don't need to get into that fact super duper carefully, But what we will do is like use it on the back end. So maybe let's do it like this. Let's notice a sub n equals a sub n plus 20 times 27, because this is true for all natural numbers k, including k equals 27. But now we can rewrite 20 times 27 like this. So this is equal to a sub n plus 4 plus 268 times 2. So you can check that 20 times 27 and 268 times 2 plus 4 are the same. But then, using this expression right here, we can absorb that 268 times 2, and we get a sub n plus 4. That means these numbers repeat every 4. And furthermore, it also tells us that there are only 4 different numbers. And we'll talk through exactly why that's true on the next board. So on the last board, we determined that our numbers repeated after every 4 steps. So a sub n was equal to a sub n plus 4, a sub n plus 8, a sub n plus 12, and so on and so forth. So in other words, a sub n was equal to a sub n plus 4m for all natural numbers m. And this here is happening mod 268, and 268 was divisible by 4, so that makes a complete loop. And the fact that 268 is divisible by 4, that means that these numbers in our circle are broken down into 4 different types. So we have numbers that are going to be equal to 3, 4, 9, and the unknown number. So let's now look at our data. So we see that the number 3 is at position 17. Well, yeah, 17, that's a useful place to know where it is, but we might as well work at that mod 4 because of this repetition. So 3 is in position 17, but now 17 is congruent to 1 mod 4. Again, we know it repeats every 4th, so that means every time we cross a number that is 1 mod 4, we know that that number is going to be equal to 3. And so I should say the number in that position is equal to 3. Now, let's use this fact. The number 4 is in position 83. So we can look at 83, which is 3 mod 4, to make a similar claim. So 4 is in position 83, but like I said, that's congruent to 3 mod 4. So in other words, every position that is congruent to 3 mod 4 has a 4 in it. And then finally, the number 9 is in position 144, which is congruent to 0 mod 4. So look, we know what numbers are in positions that are congruent to 0, 1, and 3 mod 4, but our unknown value, which I'll call x, is in position 210, which is congruent to 2 mod 4. So actually, there's a lot less to calculate than it might seem like at first. Okay, so now let's make a chart of the first 20 numbers, and this is maybe a little bit overkill, but it will help us see exactly how to finish this off. Okay, so we've got our chart of the first 20 positions along this circle and which numbers go here. And I should point out that we only really care about what's happening in the first 4 positions, but I'm going to explicitly use the fact that the sum of any 20 consecutive numbers is 75, just so that everything is a little bit more clear. Okay, so as we already argued, every position that is 1 mod 4 has a 3 in it. So let's go ahead and put a 3 in all of those positions. So that's going to be here, and then here, 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 and here. So notice there are 1, 2, 3, 4, 5 3s. Okay, cool. So now let's see everything with a 2 mod 4. Every position that's 2 mod 4 has an unknown in it. So I'll put our x there. So we've got x there, there, and then 2 mod 4, that would be 10, 14, and 18. So we've got 5 x's. Okay, nice. Now everything that's 3 mod 4 has a 4 in it. So let's see, that's going to be 3, 7, 11, 3 mod 4, so that would be 15, and finally 19. And then finally, everything which is 0 mod 4 has a 9 in it. So that means we can put a 9 here, 9 here, 9 here, 9 here, and a 9 here. Okay, great. So notice we've got 5 of each of those numbers, which means this boils down to the following equation. 5 x's plus 5 3s, 4s, and 9s. So notice I just like distributed the 5 out there. That's going to be equal to 75. So 3 plus 4 is 7. And then 7 plus 9 is 16. So we have all of this adds up to 16. So next we can do 5 times 16, which is 80. So that means we have 5x plus 80 equals 75. But that very, very quickly gets us to x equals -1. So that means -1 is in every position which is congruent to 2 mod 4, including position 210. So that means -1 is the number that we're looking for. And that's a good place to stop.